Hi everyone, this is part 3 video for the surface water budget estimation using satellite remote sensed hydrometeorological data. In this last video, I would like to demonstrate how to estimate the seasonal surface water budget components using the previously pre-processed datasets in QGIS. So now I will estimate the seasonal water budget components for this Uganda area with these prepared hydrometeorological data. So for that, I will firstly use one of the tools for this processing toolbox with the journal statistics. So I will find with journal statistics. So this one. So if you double click this one, you can see this journal statistics, the new dialog box. So for the input layer would be this Uganda. So one of the new table will be added on this Uganda attribute table. So firstly, I will select the emoji dry season, December to February. So this one, and then I will make this one with the prefix with the precipitation dry season D. So and then you need to select this count and mean only for this one. So click OK. After that, this journal statistical, the data layer would be just the temporal layer I will make. So if you click run this one, you can see this added journal statistics, the layer. If you will open this attribute table on here, you can see this Uganda layer just added these two counts and mean value for the precipitation averages for this Uganda area. So go back to this parameter. I will also make another one for journal statistics. In this case, I will use the different emoji data. This one. This would be precipitation wet season. So you need to change this PWR with wet, and already selected this count and mean value. Also, I will make this temporal layer. So if you click run, another layer you can find. So again, you need to open this attribute table. So please check this count and mean values on here for the precipitation for this Uganda area. So again, the same thing we should find with this last journal statistics, this one, and then I will add the dry season evapotranspiration data with ETW, ET dry, ETD, and all the same parameters. So again, this journal statistics, you can see, let's see this one. Yeah, you can see this EDT. And again, go back to last journal statistics and wet season. ETW, click run. So attribute table, ETW, we can see this one, and go back to lastly the TWS data. So this one for dry season TWSD. So also two parameters. So you can see this attribute table again. So TWSD count and mean values for the Uganda area. And last one. So this one. So DTWS with the wet season. Yeah, this one. And then click run with the same parameter. After that, this would be the final Jonah statistical result. So it should hold all the precipitation amount, ET amount, and the terrestrial water storage the mean values. So you can see this precipitation mean dry season and wet season. Evapotranspiration mean dry season for wet season, and terrestrial water storage for dry season, wet season you can find. So at this point, you need to delete, remove all this temporal layer and close this one. And then this should be saved as the different name. So I should save with the S3 shapefile. So this Uganda folder for the shapefile, I will save with statistics on here with the shapefile. So click OK. So it just saved. So again, I will open this attribute table for this journal statistical result. So I will add one of the new column with the area values. So if you need to do that, you need to click this one. And journal statistics field calculator on here. I will firstly the field name area I will insert, and then the field type would be decimal number, real number, and also this field ranks would be 20 and precision 2. And after that, you need to find this expression with the geometry area. So this one and area, you need to click, and after that, we will add this area values for this newly created field. So I will click OK. After that, you can see this area is just added on here. So I will just off this editing mode, stop editing mode with the save. So you can see again these three components mean value as well as this kind of area for that. So now I will save this Jonas statistical table value for the Excel CSV file. So for that, you need to click this layer tab and then save as. Format would be the CSV file, comma separated value, and then file name we need to specify. So I will use this CSV file with Uganda table. Okay, so I will save this one, and then you need to click OK for this one. So if you will see this Uganda folder that I saved this table, you can see this CSV table. So before open this one, you need to close this Uganda table first. Remove layer, and then again you can open this Uganda table with the Excel spreadsheet. with this CSV file. Okay, so I will delete all the not required table for this calculation. So I need just this PDR, PRD mean, and I don't need to discount values, so I will also delete discount. Okay, so after that you need to see this kind of all the mean values on this Excel file with this kind of area values as well. And then I will calculate the cubic meter for these hydrometeorological, the water budget components with this area. So I will firstly calculate PRD cubic meter. So for that I will multiply by this millimeter with this area meter, and then I should consider this number for calculating as a cubic meter. So okay, to calculate this one, this would be cubic meter amount for precipitation dry season for the Uganda area. So I will fix this G2 pixel with F4. After that, if I need to precipitation, wet season, and also ET dry season, ET wet season, and TWS dry season with cubic meter, and TWS wet season with cubic meter. So you need to just drag this one like this one. You can see this area is multiplied by with the same way, so you can fix this width of this all this column. And then if we want to calculate billions of cubic meter, you need to billions of cubic meter. If you want to, you need to consider this one with 10 base minus 9. This one would be billions of cubic meter for this precipitation amount volume for this area of the interest for the Uganda area. So this would be all the billions of cubic meter based computation result for that. So lastly, I will calculate this PRD minus ETD minus TWSD for the dry season. The possible, this would be the possible approximate seasonal discharge. So possible approximate seasonal discharge amount for the dry season. Okay, and also if we consider just copy, and if we just wet season, precipitation wet, ET wet season, and TWS wet season, you can also consider this one would be wet season possible approximate seasonal discharge. Okay, so I will make this kind of computation with this number minus this ETD minus this TWSD. So this amount would be the possible approximate seasonal dry season discharge. Okay, another one I will also calculate this one and this one and this one. So if you will calculate this one, the wet season for the water budget amount could not have not much seasonal discharge because it just considered with kind of the more terrestrial water storage would be enhanced with this wet season for the Uganda. So you can compute this kind of the possible seasonal discharge with this kind of seasonal water budget components. Okay? In this video, I have made demonstrations of the seasonal surface water budget component estimation in QGIS with Excel spreadsheet. So with my video tutorials, including this module, I hope to help the QGIS users to learn about satellite remote sensed data-based hydrological application analysis. Thank you for watching.